Okay, hopefully by now you've graphed the sine function. I'm going to do a couple key points with you, and then we will take up the questions below that. So when you graph the sine function, you should have saw sine 0 was 0. I'm not going to graph every single coordinate, but we are going to go through the key 5 points. The next coordinate that's important is 90 degrees, and the sine of 90 degrees is 1. So you should have had that point plotted. The sine of 180 is 0. That's the third key coordinate. The sine of 270 is -1. And then the sine of 360, because that's a full rotation of the circle, it comes back to 0. So these are the 5 key coordinates of a sine function. And do your best to draw a nice smooth curve through it. And let's answer some questions about it. So is the curve a function? It is, because if you remember from before March break, something is a function if any x value has only one y solution. So can I go anywhere on the graph and get just one answer? I can. The sine of 120 has just one answer up here. The sine of 260 has just one answer down here. So this is a function because each x value has only one y value. And the domain, a good reminder of domain from before March break. X belongs to all real numbers. And that just means you can do the sine of any number you want. So you can do the sine of 500, you can do the sine of 1,000,000, you can do the sine of negative angles, because we talked about negative angles last unit where we go clockwise. But you can do the sine of any angle you want. So x belongs to all reals. And actually, even though we just went 0 to 360, because it keeps on going, that's all you need. Okay, so you can close your squiggly bracket there. For the range, because it has a highest value of 1 and a lowest value of -1, and it'll never go above or below those values, our range will be y belongs to all reals, such that, remember from before March break, we always go lowest to highest. So -1 is less than or equal to y, which is less than or equal to +1, and then close your bracket. Okay, the cos function. Hopefully you've graphed this one already. If you haven't, pause the video and make sure that you go back and do that. But here's the 5 key points of the cos function. When you did cos of 0, you found out that it was 1. So this function actually starts at a maximum of 1. When you got to cos of 90, you should have saw that it is 0. When you did cos of 180, it was -1. Cos of 270 was 0. And then 360 is a full rotation, so it comes back to where it was at 0, which is a height of 1. So the cos graph falls from 1 through the 90 mark, back up through 270, and back up to its max. All right, to answer some questions about this is a function as well. Why? Another reason why, just like we talked about before March break, is it passes the vertical line test. So that's just another way of writing that it is a function. On the previous sine example, I gave the reason that each x value had only one y value. This is just another reason why it is a function, just to recap that as well. So that means if I put a vertical line Anywhere on this graph, it's only going to cross the function one time, making it a function. Domain. The domain, because we can do any angle we want, x belongs to all real numbers. And that is our angle, right? X is our x-axis, which is angles. And the range, because it has a highest of 1 and a lowest of -1, the range will be the exact same as it was for sine, which is y belongs to all reals such that -1 is the lowest y value and +1 is the highest y value, with the squiggly brackets on both ends of that. Okay, some terminology review. This is just on the handout, so you have it from the previous lesson, but we did go over this previous lesson. It's there if you need to go back through it. It's just axis of the curve, max plus min divided by 2. Amplitude, we could put that one in as well here. Remember from the other day, it was max minus min divided by 2. So it's very similar to the axis of the curve question or calculation, but it's subtracting. Okay, let's answer some questions about the sine function, the period of it. Because 360 degrees is one full rotation, a sine function, a normal sine function has a period of 360. The max value is 1. The min value is -1. The axis of the curve is this imaginary line that cuts the graph in half, top to bottom, and that is at y equals 0. Okay, it's because the y value is 0, and that's where it's cutting through. The amplitude, you can do that formula from above, max minus min divided by 2, or you can look at the distance from the axis to the max or min. So for this one, I'm just going to look at axis to the max because that's a lot easier than doing max minus min divided by 2. This has a height of 1, and so our amplitude is 1. Notice if we were to go from the axis to the bottom, it would also be a distance of 1. Okay, it doesn't matter that it's negative, it just matters the distance is 1. Domain, we already had that from above. X belongs to all real numbers. And range is y belongs to all reals from -1 through to 1. And then the 5 key points that I talked about when I graphed it, we're going to list them here because we're going to need them a lot in the next few days. So the first key point of a sine function is 0, 0. We look at all the x-intercepts basically. So the next x-intercept is 180, 0. And the last x-intercept is 360, 0. So those cover your 3 x-intercepts. And your max is at 90 and 1. And your min is at 270 and -1. So I did x-intercepts first, and I did max coordinate, and I did min coordinate. Okay, I want you to do the same thing for the cos function. So the cos function is given to you there, and I want you to go through and fill in all that chart. I'll do the key points with you though. Reading them from left to right, the first key coordinate is 0, 1. That's here. This one, if you look back to your other graph that we did, was at 90 and 0. The min coordinate is at 180 and 0. The next x-intercept is at 270 and 0. And then the final key coordinate is when it comes back to a height of 1, which is at 360 and 1. Okay, so those are the 5 key coordinates for a cos graph. Okay, one more quick example about a sinusoidal function. And then I have some homework to post that you can work on Desmos. Okay, Sarah's sitting in inner tube in a wave pool. The depth of the water below her in terms of time can be represented by the graph shown below. What is the period? Well, the period is the time it takes to complete one full cycle. So we need to look at her starting spot, and we need to look at when she gets back to that where it's about to repeat. So she gets back to 2 here, but this is not where it repeats because she still goes down further. So we have to get back to 2 when it starts to come up again. So that one full cycle is actually right here, because we can take this red curve that I put on there and we can repeat it here and here. Okay, so that means the full period is 3 full seconds. Okay, it's a common mistake that people look to where it gets back here. Notice that's only the upper half of the curve though. You need a full cycle that shows the upper half and the lower half of the curve where it's about to repeat. So it's, if I could put the blue in here now, then that would be a second repeating pattern. And if I could change it to green, there would be my third repeating pattern. Okay, so we're actually looking at 3 full cycles in that graph. Her maximum height, well, we need to look at our scale a little bit. Every 2 blocks is 0.4. So that means that this up here would actually be 2.4. And that is her height above the bottom of the pool. The minimum height she gets to is 1.6 meters above the bottom of the pool. And her axis of the curve would be the spot where I can draw an imaginary line that would cut through the middle of the graph top to bottom. So I could do it mathematically by doing 2.4 plus 1.6 and dividing by 2. Or because this is a fairly simple graph, I can actually just see that this imaginary line is what would cut the graph top to bottom. So our axis of the curve is at y equals 2. And then our amplitude is that distance that she goes up and down from the axis. So notice she has a distance of 2.4 up, or sorry, not 2.4, 0.4, excuse me, and a distance of 0.4 down. So this amplitude is 0.4. If you don't like that method, do the method I was talking before where you do max minus min divided by 2. I'll show that here. So 2.4 minus 1.6 cut in half. If you type that in the calculator and make sure you hit equals before you divide by 2, you'll get an amplitude of 0.4. Okay, so that's another way of doing it. Okay, one more thing I wanted to show you when you're working with Desmos and trig. It's really important when you're graphing sine. First of all, you can just type the word sine in. So bring up your keyboard, type in sine. You don't need thetas for Desmos. You can just do sine x. But notice that this is not in degree mode. Okay, so this graph is doing rotations every 6 units, basically. This is what we call radian mode. You use it in grade 12, but you don't use it in grade 11. So in Desmos, when you're using trig, you want to go to the wrench up here. You want to come down to degree mode, and you want to make sure that that is in green. So you're off radians and you're in degrees. So make sure that you're clicking that. And then if you want to do an x-axis, so notice when you did that, it elongated the graph. We're going to pinch to zoom it out, but it can still be a little frustrating because you have scales of 100, 200, and 300. So come back to the wrench, and on the x-axis, you may want to step up by 90 degrees at a time. And you may even want to go negative 360 to positive 360 on the x-axis. And then since the sine graph typically goes -1 to +1, I just go maybe -2 to +2. Then when you come back here, you've got a nice picture of where the sine graph would start and where it would end. Now, if you only want one cycle, let's say you don't want it to keep repeating, because you are going to see a graph that keeps on going forever and ever and ever. If you're only focusing on one cycle, you can actually indicate on Desmos the specific domain. So this is where what we learned before March break is helpful. Come to your sine x graph, go back to your keyboard, pull up the squiggly brackets, and let's say we want to graph only from 0 to 360. We can put in 0 less than or equal to x, which is less than or equal to 360, and we can close that squiggly bracket. Oh, never mind. I guess it automatically closes it for you. And there we have one cycle of the sine graph. Okay, and if we wanted to do cos, we could do the exact same thing here. We could go y equals, type in cos x, and I think we can probably even, well, I thought we could maybe copy that domain so we didn't have to retype it all the time. Maybe you have to retype it. So 0 is less than or equal to x, which is less than or equal to 360. And now we have both the sine and the cos graph on the same grid. Okay, and we have just one cycle of it. Again, with Desmos, if you want to hide one of the graphs, you can just touch the red or the blue, and it'll hide the pictures so you can work on it and see what's happening. Okay, this will be useful because we're going to be doing transformations of graphs. So for example, we're going to do y equals sine of x plus 5. And we're going to be seeing what that what that does to the graph, how it shifts it up 5, and what happens if we put, let's say, a 2 in front of that, or what happens if we make that negative, kind of like in quadratics when we did all the different transformations of quadratics. That's what we're getting to with sine and cos later this week. Okay, so knowing how to do trig with Desmos is going to be helpful, and you need it for today's homework as well. All right, that's it for today's lesson. Please make sure everything is filled in on that worksheet or copied out and done on your notes. All right, enjoy your day, guys.